Okay, so for question 8b, okay, is a bit different because it requires knowledge of the properties of parallel lines. Okay, so one thing you have to take note is when two lines are parallel, right, they are in the form of y equals to mx plus c. This m here is your gradient, right, and parallel lines have the same gradient. Okay, so parallel lines have the same gradient, okay, if they are parallel. So as such, Amy was asked to solve to a pair of simultaneous equation. Right, they ask you what are the possible values of C and D. Now if I were to sub this here, okay, you realize that when I expand out, because here y is 2, right, so your C is definitely 8. So 8 is a possible value of C, because if I have 2y equals to 8x plus D and I reduce it to a single y value, this will divide by 2, right, and will give you 4x, which is the same gradient as here, right? So that means these two equations will hence be parallel because the gradient is the same, right? So your C has to be 8. However, right, if I were to compare my equations here, sorry, this should be 10. Okay, if I were to compare my equations here, D cannot be minus 10 because they must have different y-intercept. Okay, right, this is the mistake I made in class. They must have different y-intercepts. Okay, and hence D can be any value but 10, right? Because if I were to sub this in here, right, and replace this with minus 10, I will get back minus 5, which is the same y-intercept. So that's not possible. Okay, so any y-intercept is possible except for minus 10. So D can be 4, example 6. Okay, anything but minus 10. Okay, so if you ask, sure, why is it cannot be minus 10? Because one, for no solution, it is same gradient, but y-intercept must be different, right? Y-intercept is different. However, if it is minus 10, then we go back to our graph here, right? If 2y equals to 8x minus 10, when you divide it, it is 4x minus 5, right? This is the same as the exact same. When you reduce it, it becomes the same as the other equation, which is y equals to 4x minus 5, right? And based on this definition, they are the same line, and because they are the same line, there will be infinitely many solutions because every point of this line is touching this line. Every point of this line will be touching this line. So that means like they overlay on top of each other. So there are infinitely many solutions, right? But the question says no solution. So same gradient but different y-intercept. Okay, so sorry for the mistake earlier. Okay, I hope this clears up everything. Please ask if you have further questions.